So what was going on in Africa at the time? What were the pressures that led to this uncomfortable compromise, upright walking?
5 or 6 million years ago, Africa was drying up. There was a great continent-wide drying up, a desiccation, with the forest retreating, the great wet forest of Central Africa, going back and back.
Such formerly widespread, lush, easy habitats, if you like, would have been drastically reduced. They would have been shrunk apart into little islands so that little areas would survive here and there. Even in these little surviving refugial islands, changes would be felt. The margins, the desert, the arid margins would encroach. Seasonality would increase. Certain foods would disappear. And the pressure would be on those creatures caught in these little islands to change or disappear altogether.
And under those circumstances, it seems that the first step in the human direction appeared.
This is where we began, in the forest. In many ways, the earliest apes looked different from modern apes, and they may have moved differently, too, along the tops of the branches. We've done a little evolutionary experiment, a bit like the experiments all those millions of years ago. Hey, pal, you're too big to walk on that branch. How are you going to reach the fruit at the end? Thing is, the trees are disappearing fast, and there aren't many places you can still hang out.
There's no doubt about it that forest cover in Africa shrunk very dramatically, and that any creatures that were dependent on sheltering in the trees, on fruits and leaves from the trees as food, would be dramatically affected by this.
Bravo, but there's not much left to eat around here, you know, and the next trees are miles away out there on that other side of the plain. Don't look so worried. All that hanging and climbing is good practice for being upright like me. Hey, you're ready-made for standing up.
I think there can be very little doubt that the earliest hominids arose partly, at least partly, in response to this major climatic change.
Say, you're going to have to sharpen up your act if you want to survive down here. Your legs are too short for serious walking. Your arms aren't long enough for serious climbing. You better start making up your mind pretty soon. You need a better grip, a little more control. You know, I think we're beginning to get somewhere.
When we became upright walkers, we set in motion a number of adaptations, all of which were critical to the evolution of modern man. That was the adaptation that freed the forelimb for manipulation of the environment. And if we study modern-day chimpanzees and apes, and we look at these animals, what we find is that they have something called K-selection. That is, they are very intensely adapted to the care of single offspring. And those offspring become so important to them that anything, any behavior that would tip the balance and make those offspring more likely to survive would be strongly selectively favored. One thing that would do that is if males were to become secondarily involved in the parenting process. A way they can do that is to occasionally collect highly valued items of food, such as reptiles, amphibians, eggs, nestlings, grubs, worms. These items are extremely high in calories, in protein, and in rare fatty acids. If a male were to obtain these and provide it to a female, it would greatly improve the time that she has available to care for the infant. It would raise the survivorship of the group and of the infant, and it would be an intensively favored form of adaptation. But that form of adaptation requires walking upright so that you can carry items like that. Adopting upright locomotion must have improved our reproductive rate. And it set in motion a whole series of adaptations that would eventually lead to the evolution of modern man.
Suddenly, these early creatures, the ancestors of which used to live in the trees, in the high canopy forests of Africa, found themselves in much more open savanna, and they had to adapt or die.
There's a big difference between a few staggering steps, like today's chimps might do, and using just 2 legs all the time to travel real distances.
Hot? Tired? Well, like I said, he's got a long walk to reach the next forest. Take it from me, pal, it's a lot better on your hind legs. Try it that way. Bravo!
One of the major problems our ancestors would have encountered as they attempted to colonize more open habitats would have been heat stress. There would have been very strong selection pressures on the first hominids, favouring any adaptations which either reduced the amount of heat they gained from the environment or which helped its rapid dissipation. Now, bipedalism itself has advantages in hot savanna conditions. As the sun climbs in the sky throughout the day and the problem of heat stress increases, the area exposed by the quadruped stays roughly the same, but that of the biped falls dramatically. And at the hottest time of day, around noon, a biped would only be exposing something like 40% of the surface area that's exposed by a similar-sized quadruped, a massive saving in energy gain. The second advantage is that it increases the rate at which heat can be lost in savanna conditions. Out on the savanna, down here by the ground surface, the air is relatively slow-moving and hot. That means that relatively little heat is going to be lost from the body by the process of convection. The skin becomes warm, and these warm areas show on this thermographic image as red. As I stand and become a biped, the situation changes. The air up here is cooler, and it moves more freely over my body surfaces, carrying away more heat. In fact, calculations indicate that something like 1/3 more heat is lost in this way. The skin cools, and this can be seen in a shift from red to green to blue. This increased convective heat loss means that less water is needed, therefore the animal needs to drink less and secrete less sweat.
Habitually standing and walking on 2 feet was a major evolutionary advance for our ancestors. It required many modifications to the bones and muscles, and it was probably accompanied by other changes, such as hair loss and better sweating mechanisms that helped to dissipate heat. How many thousands of years it took to accomplish all these changes is not known, but if the changes were critical for survival, then the transition, in evolutionary terms, could have been very rapid indeed.
From 5 million years ago, we had set out on a completely different course. The environment had changed. The forests were in retreat. The climate was drier and hotter. Evolution selected upright walking as a better way, in the short term, to survive and thrive.